We pour so much time and energy into making AI smarter, right? Teaching it to learn from this just vast ocean of human knowledge. But as these models get more and more powerful, we're hitting a really critical challenge in AI alignment. How do we actually control what they learn? And maybe even more importantly, what they don't? So, what if the key to a safer AI wasn't just about cramming in all the right things, but about actively, unlearning all the wrong ones? That is the absolutely fascinating question at the heart of the research we're diving into today. To really get why forgetting is such a big deal, we first have to take a quick look at the alignment problem that developers have been wrestling with for years. Okay, so large language models, LLMs, they're trained on these staggering amounts of data scraped from the internet. And the internet, as we all know, it contains everything. This means these models can accidentally learn to generate some really harmful content, leak copyrighted stuff, make up facts, hallucinations, or even repeat private data. These are exactly the kinds of misbehaviors we need to tame. For a long time, the reigning champion for fixing this has been a technique called reinforcement learning from human feedback, or RLH. Think of it as this super sophisticated carrot and stick method. You have humans providing examples of good answers and ranking different model responses. This trains the AI to prefer the helpful and harmless outputs. Honestly, it's the method that powers many of the AI assistants you and I use every day. But here's the catch. The champion has some serious weaknesses. RLHF is incredibly expensive. You literally have to pay people to sit there and write all those good examples. It's also a computational beast, involving all these complex training stages. And because of all that, it is slow. And that is not ideal when you spot a bad behavior and need to patch it like yesterday. And this is where our new contender enters the ring, LLM Unlearning. It is a clever, powerful alternative that basically flips the old approach right on its head. This quote from the paper, it marks a huge paradigm shift. Instead of pouring all of our resources into teaching a model what a good answer looks like, what if we just focused on teaching it what a bad answer is and just told it, hey, don't do that? The difference here is just striking. RLHF, our champion, it needs both good and bad examples to work. It's pricey, and its goal is to be broadly helpful. But Unlearning, the challenger, only needs examples of what you don't want, and this makes it unbelievably cheap and efficient with one laser-focused goal: just stop the bad outputs. So how in the world does this actually work? What's the secret weapon that lets an AI just forget something? Well, this secret is a technique called gradient ascent, and it's a beautifully simple idea. See, regular training, that's called gradient descent. It's like a hiker walking downhill, always trying to find the lowest point, which represents the best, most correct answer. Gradient ascent does the exact opposite. It sees a bad answer and starts walking aggressively uphill, trying to get as far away from that bad spot as it possibly can. So the researchers built this brilliant three-part formula around that idea. First, they use that gradient ascent to unlearn the bad output. Second, they reinforce it by forcing the model to associate the bad prompt with just random, nonsensical text. It basically scrambles the connection. And third, and this is key, they make sure the model still performs great on all the normal good prompts. It's like surgically removing the bad behavior without damaging the model's overall usefulness. Okay, so that's the theory. But does it actually work in practice? Well, the researchers put Unlearning to the test in the proving ground. And here's a great visual right from the paper. On the left, you've got the original model giving a harmful response to a sensitive question. And on the right, after Unlearning, the model just outputs a harmless, noncommittal answer. It's completely forgotten how to be harmful in that specific context. And the numbers? They totally back it up. The original model had a 53% harmful response rate on prompts it had never seen before. After applying the Unlearning technique, that rate just plummeted to 7%. That is a massive, massive improvement. And this wasn't just some one-trick pony. The researchers showed this technique is incredibly versatile. They used it to erase copyrighted material, dropping the leakage rate from over 70% all the way down to 0. They also used it to reduce hallucinations, teaching the model not to give factually wrong answers. It just works. All right, but now for the main event. We've seen what the challenger can do, so how does it stack up in a direct, head-to-head comparison with the reigning champion RLHF? Let's look at the scorecard. Full RLHF got the harmful rate down to 7.5%, which is great, don't get me wrong, but it took about 8 hours of computation. Unlearning, It got the rate down to 7%, so slightly better, and did it in less than 12 minutes. A better result in a tiny, tiny fraction of the time. Let me just put that another way. The unlearning method achieved championship-level performance using just 2% of the computational time. That is a complete and total game changer for efficiency. So what's the real legacy of this new contender? Why does teaching an AI to forget actually change the game for safety and alignment? Well, what this research gives developers is, essentially, a fast, cheap, and super effective delete button for specific AI behaviors. When a problem is found, they no longer have to go through a long, painful, and expensive retraining process. I mean, this was just a monumental step forward. This provides a critical safeguard for deploying AI in the real world. Its influence is huge because it opened the door for this whole new field of research and to what we call model editing. Instead of just training models to be generally good, we now have a powerful way to surgically remove specific flaws after they're already out there. This makes the AI systems we interact with every single day fundamentally safer and way more adaptable. For so long, the focus in AI has been all about the accumulation of knowledge. But this research, it suggests a profound new direction for AI safety, one that kind of echoes concepts like our own right to be forgotten. It leaves us with a really critical question. In this quest for aligned, trustworthy AI, could the power to forget be just as important as the power to learn? This is for entertainment purposes only.